online and also listening to us. My name is Engineer Holiday. Also, I want to thank God for today and those that have been enjoying this class in the background, those that have been listening to us at home, students, and also I want to appreciate my crew member and my lovely wife. Now let's start this video. This class is Upthrust and flotation. We are going to major upthrust and flotation. Though the topic is density and upthrust, but we have talked about density last class, and I also talked about relative density in the last class. Now, but there's something I need to talk about under relative density, which is what? How to use relative density, but to determine what? The relative what? Density of maybe, let's say, a kerosene using relative density bottle. Now, how do we determine what? To determine the what? The relative density of kerosene using relative density bottle. Now, what are the things you are going to need in the apparatus? You are going to need what? Your electronic what? What they call it? Balance. You need electronic balance. You need your kerosene. You need water. You need kerosene. You need water. You need funnel. And you need beaker. You need what? Electronic balance. Then you need all these ones. You need water. Now, what do you do first? Now, this particular one, I want to talk about it because JAM always on other A-level exams, SAT also, sometimes they said a Cambridge exam, they set questions that relate to this aspect. And also SSC and other related exams. Now, first thing you do is to have your bottle. Your bottle will be weighed. You weigh your what? Weigh the what? The density bottle. The relative density bottle. And call it what? Call it M naught. Now you weigh the relative what? Density bottle, and we will call it a what? M naught. Then what you do next is to what? Fill the what? Fill the relative what? Density bottle with water. When you fill it with water, you call it what? Call it what? And record it. Then when you fill it with water, weigh it with electronic balance, and you name it what? M1. That means that after you pour water inside it, you fill it with water and call it what? M1. Then you dry the bottle. You know why you need to dry the bottle? Because if you don't dry the bottle, some particles of the water will be what? Will be on the surfaces of the relative density bottle. So you dry it. One of the precautions is that you dry it. When you dry it, you dry the what? Dry the what? Relative density bottle. And then fill it what? Fill the bottle. The relative will fill the bottle with kerosene. And what? Record the mass after weighing it as what? M2. Now, having done that, now what you do now is now what? For us to what? Know our what? Relative density bottle. Don't forget the empty bottle, empty what? RD bottle, we call it what? M naught, abi. Then we said empty relative density bottle plus water is equal to what? M1. Then if you can go through this now, you will notice that how do we get the mass of water? So mass of water only will now be equal to what? M1, you subtract, because this one is getting what? Mass of relative density bottle, empty bottle plus water. So when you now remove this empty bottle from the combination, what you are going to have is what? That is M1 minus M naught will give us what? Mass of water only. Then also the empty bottle, empty relative density bottle plus what? Kerosene. We recorded it, we check up, we recorded it as what? Empty. So, but how do we get what? The mass of what? Of kerosene only. Only. That is to say, we are going to subtract what? M2, the combination, from what? The empty bottle, which is M naught. What I would have now? M2 minus what? M naught. Having done that, we can now calculate our what? Our what do you call it? Relative density. Don't forget, kerosene, you've emptied this one before and dry it before filling it with what? With kerosene. You fill the bottle. Now, let's say we want to now calculate our relative density bottle or relative density. The relative density of the kerosene now, relative density of kerosene is equal to what? Mass of kerosene over mass of kerosene. Now, at what? Maybe the volume of the relative density bottle, the volume of the kerosene, let's say 10 centimeter cube. Let's consider the volume as 10 centimeter cube. So mass of what? 10 centimeter cube of kerosene over mass of what? Of 10 centimeter cube of water. So that's why some textbook will tell you mass of any volume of kerosene over mass of equal volume of water. Many of you have heard of before. That is, they're telling you that the kerosene volume and the water volume are being considered at the same volume. That is to say, if the relative density bottle, the capacity of the volume of the relative density bottle is 10 centimeter cube, that is to say, the water must be 10 centimeter cube, filling the what? The relative density bottle. And the kerosene must also be what? 10 centimeter cube, filling the what? The bottle. So that means that we are having equal volume of kerosene and water. So mass of what? Of 10 centimeter cube of what? Of kerosene, and over mass of what? 10 centimeter cube of water. That is another definition for relative density to define it. So what is mass of kerosene now? We are going to have what? M what? 2 minus M naught all over what? M1 minus M naught. We give us relative density. Sometimes we write it like this: mass of kerosene minus mass of empty what? Relative density empty or empty bottle over mass of water minus mass of empty bottle is equal to what? Relative density. Density of what? Kerosene. So to get mass of what? Relative density of kerosene, you take mass of kerosene minus mass of empty bottle, empty relative density bottle, over mass of water minus mass of empty bottle. Don't forget, once you get your what? Relative density, multiply by what? 1000 kilogram per meter cube, you get what? Density. So to convert density in what? In kilogram per meter cube, multiply the relative density by 1000. I think that one is clear. So that is the formula we will be able to derive from this experiment and ensure that the bottle is dry before what filling it with kerosene. Ensure that you empty the bottle, empty it before what filling it with what, with kerosene, and ensure that the surface of the what, of the relative density bottle is not dried. What are the things you can take home from this C? Is that that formula must be what is very very important, because questions do come out from there. Number two is that what relative density bottle is what is used to determine the relative or to determine the density of liquid. Don't forget the end product now is that to determine the this kerosene now. To now be, if you can get the relative density of kerosene, you can actually get density of kerosene. How? Just what? Multiply the relative density of that kerosene, multiply it by what? 1,000. You have gotten what? Density of kerosene in kilogram per meter cube. I pray God will give you understanding as we go in Jesus' name. Now, let's go to Upthrust. I think I'm done with that. Upthrust, which is the word, the main topic for today. Upthrust and flotation. Upthrust and flotation. Now, what is upthrust? Now, upthrust is a force, or you can say is an upward force, is an upward what? Force on a body when what? Immersed in what? Of a body when immersed in liquid. Or you can say fluid. When you say fluid, I'm trying to talk about liquid or gas. Let's take an illustration. Now, let's have our body here. A body placed, let's say it's placed in what? This liquid now. Now, one of the questions they ask, which is an examination question at this level of what? This topic under upthrust, is that they will say when a body is placed in water or in a liquid, how many forces are responsible, or how many forces act on the body? Number one is what? The weight. Number one is weight of the body. Don't forget the weight of, and number two is the upthrust, is an upward force, U. So upthrust is your second word, and that upthrust is where we are going to concentrate on. Upthrust. Upthrust is a force, it's an upward force. Don't forget, it's acting upward. You can see it clearly. When a body is immersed in water, it's an upward force on a body when what? The body is immersed in water. When what? Immersed in water or in liquid. Now, that upthrust we are talking about is experienced. It is experienced by what? Body or bodies, anyone, by a body, let me put the word, when placed in liquid, and it reduces the what? It reduces the what? The weight of the body. So that is not like a figurehead. Why is it functioning? Now, what we are saying now is that upthrust, it is experienced by a body. It is experienced by a body. You can write it down. That's how I'm slowing everything down, so that if at all you want to write, you can see right. So if at all you not see what I'm writing, I think you can listen to what I'm saying. You have to learn it, how to write fast and how to dictate fast. Very, very important. The time will not be enough for us. I said what? What? Upthrust is experienced by a body when immersed in water, and it reduces the weight of the body. Upthrust is experienced by what? In water. When the body is placed in what? In water, it's an upward force that is experienced when the body is placed in water and reduces the weight of the body. Now, what we are saying now is that when a what? A body is what? Is what? In a liquid. Is in liquid. It experiences or it experienced a force acting upward, which what? Reduce what? The weight of the body. I've simplified it now. So this is what I've just written now. So that means when a body is in liquid, it experiences a what? A force. And that force is an upward force which reduces the weight of the body. If you go to what? Most of us, I don't know whether you stay in a local environment where you go to fetch water. When you put the bucket of water inside the well, you will notice that when the water penetrates deeper into the well, or into the water rather, there will be you feel lesser weight from the string tied to the what? To the bucket that you are using to fetch the water out from that river. When it enters the water, there will be a light. It's as if the weight has been lost. The water will now be lighter than, or the weight of the bucket will now be lighter than what it is. But when it's out of the water, it will not be heavy. It means that something is what? Assisting. Something is reducing the weight of the object while in water. But immediately it's out of the water, if the weight return back. So that is to say, this upward force must all be inside the what? The liquid or the fluid. But once it's outside, there is no what? No upthrust any longer. Now, it's what? Upthrust displays what? That thing I just explained now. Upthrust displays is what? A volume which is what? Which is equal to the what? The volume of object when it is what? Totally what? Immersed. I want to explain this one again. Now, upthrust displays a volume which is equal to the what? To the volume of the object when immersed in water. That is to say that if I place a what? A body here like this, look at the board. Let me clean this side so that we can have a clearer picture. What I'm trying to say is that in a simple language, my dear, if I place a body here now and fill it with what? Put a liquid here inside this what? Container, a beaker or anything. And I place a body inside. I place a body inside, totally. When we say totally immersed, meaning that there is no part of the body showing outside. Everything enters inside the liquid. Now, immediately it enters, there will be a rise. Let me put it that way. Maybe you rise from where? From V1 to V2. It will rise from where? V1 to V2. Now, if you want to calculate the volume of this object, let's say the volume of the object is V0. The volume of the object, it will be equal to what? The volume 2 minus volume 1. That is to say, the volume of the object itself is equal to the volume of the what? Of the liquid displaced. So the volume of a what? Of the liquid display is what we call the volume of the object when the body is totally immersed. Totally immersed means that everything inside the water or the liquid. So that one is clear. So please take note of that. Now, what is the formula for Upthrust? What is the formula for Upthrust? What is the formula for Upthrust? Now, don't forget, Upthrust means what? Upthrust means what? Lost in what? In weight. The apparent, let me call it, apparent what? Apparent loss in weight. Upthrust is what? Is called what? Apparent loss in weight. Upthrust can also be called the weight of the what? Of the body displaced. I'm giving you this language because they might not come directly. They might not come directly. They might not ask you Upthrust directly. Indirectly, Upthrust means what? Lost in what? Apparent loss in weight. Upthrust also means what? Weight of the what? Of the body displaced. So anyone that asks you, please take note of that. Or weight of the liquid displaced. Let me put it that way. Weight of the liquid displaced. Better thing. Weight of the liquid displaced. That's what we call Upthrust. Now, by definition, now, let me give you two definitions, two powerful definitions from here. Now, let's weigh this body and call it what? W in air. This what? In air. And this one is what? Let's put it inside the liquid. Fully in the liquid, let's call it weight in what? In liquid. Now, we have placed what? We have two diagrams here. Let's call this one figure A, and let's call this one figure B. Now, in figure A, we are seeing a body, a weight, being what? Suspended in air. And in figure 2, we see a weight. I tie a what? A string to it, so that you can see that. Because somebody will ask, how does he enter the water? That's why I tie a string to it. So one is what? Suspended in air, and one is suspended in liquid. Now, the upthrust is equal to what? Weight in air minus weight in liquid. So if it is water now, that this body, if it's water, H2O, it will not be weight in water. Don't forget, the weight in air is always higher than weight in water or liquid. Weight in air is always greater than weight in liquid. Weight in air is always higher than weight in liquid. So the loss in weight, which is the apparent what? Loss in weight, the apparent loss in weight will now be likened to be equal to what? We say weight in air minus weight in liquid. Now, what we are going to do now is, having known that, we now say upthrust also can be given as, it's also the same thing as, let me use U, the density of liquid, in which the body is what? Immersed, times the volume of liquid displaced, times gravity. So take note of this. I say that what? That upthrust is equal to what? Weight in air minus weight in liquid. Similarly, we can say density of liquid times volume of liquid displaced times gravity. Now, the problem students always have is the language volume of liquid displaced, which I want to explain. I want to explain this word volume of liquid displaced. The volume of liquid displaced is the part of the body in water or in that liquid. Now listen and listen so good. The volume of liquid displaced is the part of the body that what? That enters the liquid. Now, for instance, let's take something here. Let's take a diagram of this kind. Let's say we have what? This is the body. This is very large what body. And let's say what? Some part enters. Let's say this part enters the liquid. If we check now, there are some parts that is still above. Some part is above, which is not. Let's call this one V above. VA, that means VA means above. And what? Let's call the part of what? Let's say V in. Now, V in is volume inside the water, while V naught is the volume of the object. So, volume of the object, don't forget, will be equal to mass of the object over density of the object. The object you are referring to is this object. The object will have its own mass and will have its own density. And that mass of this object that you have placed in that liquid divided by the density of the object gives us the volume of the object. Now, having known that now, what we need to do now is, how do we know the volume of the liquid displaced? I just told you that the volume of the liquid displaced is that volume that is in water. Now, so volume of the liquid displaced, now don't forget, volume of what? Of the liquid displaced. That is what? What I write as what? VLD, volume of what? Liquid displaced, VLD, is equal to volume of what? Liquid displaced is equal to volume of the body in liquid. So volume of the liquid displaced is actually talking to, or is talking about what? The volume of the object in water. So that is to say, upthrust now will now be equal to what? Density of the liquid times VIN. That's just the VIN. VA is volume above the water. The part of the water of the body that did not enter the water is this one. Is not the volume of the liquid displaced. So that is the volume of the liquid displaced is the one that we want, that I'm shading now. Look at the shaded portion. There are two parts of the body there. That shaded part is what we call the volume of the liquid displaced times what? Gravity. So that is what? The volume. Now, but there are some cases where the volume of the what? Object, because we cannot find this one. Most of the time they give us in form of volume of the object. They can say half of it is what? Maybe half of the entire volume is in water. Maybe what is inside the water? Inside the water, maybe half of the entire volume of the object is being displaced. That is to say, you are going to find the volume of the object and multiply by what? Half of the what? Of the object. That is to say, they can most of the times they don't give you this one. They give you the volume of the object by what? Giving you the mass and the density. When you have gotten the volume or by what? Mass of the object divided by density of the object. I'm not saying density of the liquid. There are two densities here. Density of liquid is based on density of the object. You get the volume of the object. Then after getting the volume of the object, you now, let's say half of it is displaced in water. That is to say, you are now going to multiply. If you have gotten what 10 centimeter cube at your volume, for example, after solving, you now more. That means that 5 centimeter of this what 10 centimeter is what? Is in water. While 5 is above. 5 centimeter cube is in water. That's what you are going to use as what? volume in, which you are going to take as your what? Volume of the liquid displaced, which you are going to take as what? Volume of the body in liquid. But what if everything enters the water? Like what I have here, my dear. Now, in this case, now, it's a different scenario when the body fully immersed in water. This is what we call partially immersed. Partially immersed in water. But what about a case where it's totally immersed? In a case of totally immersed, the volume of the object equal to the volume of the liquid displaced. When it's totally immersed in water, that means when we think about totally immersed, everything about the body is in liquid. In that case, the volume of the object equal to volume of the liquid displaced. In that case, we can now say the mass of the object divided by what? Density of the object. So if mass of the object divided by density of the object is now the what? Volume of the liquid displaced equal to volume of the object. And don't forget, they will give you the mass of the object and they will give you what? The density of the object. So you divide them accordingly. You have actually end up in getting the volume of the liquid displaced. You have also gotten the what? The volume of the object in liquid. You have also gotten the what? The volume of the object. Because according to Archimedes, according to Upthrust, Upthrust is saying that what? The volume of the liquid displaced when a body is totally in what? Immersed in water or in liquid is equal to the volume of the object. So therefore, ladies and gentlemen, boys and girls, when a body is what? Totally immersed, it is equal to volume of the liquid displaced and it's equal to volume of the object. So I've given you the formula now, how to find it now. So that means that when it's totally immersed now, that means Upthrust become what? Density of liquid times volume of the object times gravity. Which will now be what? Density of liquid times what? Mass of object over density of object times gravity. So somebody else can take this one as what? So in the question you can see, you can be given two density. Density of liquid, which is density of liquid itself. They will give you density of the object, which is density of the object itself. They will give you mass of the object and give you what? G is acceleration due to gravity, which is what? Having a constant value of 10 meters per second square or 9.8 meters per second square. So they will always give you, it's not something you show ski about. Don't show ski in the exam. They will give you, if they give you T, G as 10 meters per second square, use it. If they give you 9.8, use it. Is what? Correct. Now we go to what? Explanation. To really explain everything I have said here is what we call Archimedes principle. The man called Archimedes totally explained what is called what? Upthrust. It says that when a body is totally immersed or partially immersed, experience an upthrust. It experience what? An upthrust, which is equal to the weight of the body displaced. Hello? It says that when a body is what? Totally immersed or partially immersed, Archimedes principle totally explain everything about upthrust. He's saying that scientist said that if when a body is totally immersed, means that when everything enters water, which is when volume of the object equal to volume of liquid displaced equal to mass of the object over density of the object, or partially immersed when what? They will tell you the amount of water, the amount of fractions that will be inside the water. The fraction in water is what we call the volume of the liquid displaced. They can tell you, if they tell you 4 over 5 is above, 4 over 5 of the volume is above, how many will be below? 1 over 5. Don't forget, you just subtract 4 over 5 from what? 1, you get 1 over 5. So 1 over 5 of the volume, which is 10, will now be 2 centimeter cube with the volume of the liquid displaced. So sometimes some question they will give you volume above to be what? 4/5. Then you now need to think that if 4/5 is volume that will be above, that means the one that does not enter the water. That means the one that enters the water will now be what? 1 minus 4/5, which is what? 1/5, which is what? Don't worry, you will see a video on that. My wife will do a video on butterfly method. Just expect something like that on that fraction. Now that it does that, so that is clear. Now we get what he said: when a body is totally immersed or partially immersed, it experiences an upthrust, which is equal to the weight of the body. I told you upthrust is equal to what? Weight of the body of the liquid displaced. I told you. Or also, you have written the notes down if you have been following the class. I also told you upthrust is equal to what? Apparent loss in weight. Where I told you what? Weight in air minus weight in the what? In a liquid. So apparent loss in a liquid is equal to what? Weight in air minus weight in what? In liquid. So we have explained Archimedes principle. So according to Archimedes principle now, everything that we have said is correct. So we now go to what we call flotation principle, which is the last thing for today. Flotation. That's where we are going to end the topic for today. Flotation. But before I end this now, I want to ask you a question. I want to see whether you are smart. And I know you are smart. I know. Now, look at the board. I have a body immersed in what? In liquid. Let's say everything entered the water. Let's see everything with the explanation I've explained now. Or with everything I've done now. And you are giving mass of the object. You are giving density of the object. You are giving density of liquid. This is a body itself. That with a volume. Totally immersed. Now, we weigh the body in what? In air. This air. We suspended with thread. Let's call the thread the tension. Let's call it tension T. Tension T. That you know that when you are putting, when the person want to draw water now, as you suspend the weight in air, it's heavy. But when you put it in water, it's more lighter. Because why? There is an helping force called what? Upthrust acting vertically upward. Now, what I want to do now is this. If you check this one now, how many forces are acting here? How many forces? 3. When a body is suspended with a string inside the water, there are 3 forces. But when a body is placed in water without a string, there are 2. Weight and upthrust. Now this one has 3 forces. Tension due to the string that we tie to the weight. Upthrust due to the what is the mass in water, so upward force, and weight of the body due to gravity. So now, how many forces are going up? We have what? 2 forces are going up. According to vector, say well, when 2 forces are going up, add them together, the same direction. T plus U, that means T plus U, tension plus upthrust equal to what? Weight. Weight is the only force going down. Look at it now. The net force for the what? The body force is for the force is total force going up is what? There are 2, upthrust and tension. While only 1 force going down, which is weight. And that will give us tension equal to what? Weight minus what? Upthrust. So in that case, that means to find tension of this one, to find the tension in that string that used to immerse water is what? Weight minus upthrust. And what is your weight? Weight equal to mg minus, what is our upthrust? Don't forget, this body is fully immersed in water. So it now be what? This is mass of the object times gravity is equal to weight. Mass of the object itself times gravity is equal to weight. How do we get upthrust? Upthrust is what? Density of the what? Of the liquid times what? Volume of the object. Why? Because the volume of the object equals the volume of the liquid displaced. Why? Because the body is totally immersed in water. Why? Because when the body is totally immersed in water, the volume of the object is equal to what? Volume of the liquid displaced. Then will not be what? Times G. Somebody else can make the question so difficult that these people can be so wicked that they now what? They did not give you mass of the object. They now what? Gave you what? Density of the liquid and what? Volume of the liquid. Don't forget, mass is equal to density times volume. Mass is equal to density times volume. Knowing fully well that density equal to mass over volume. I said it before from the beginning of the course, part 1. Now, this and that means you can say density of object times volume of the object times G minus density of liquid times volume of what? Liquid, or volume of object times G. So any of this one is suitable for solution. Please take note of that. This one is, any of these two is better. Sir, does it mean that weight in liquid is the apparent weight and the weight in air is the real weight? Now, the weight in liquid is apparent what? Weight. While what? Weight in air is the real weight. So that is to say, the difference between the two of them is what we call apparent loss in weight. That means what we are saying now, that the mg is what? The real weight. The one in water is the, if we put a word spring balance here, that spring balance will read the lesser what? A lesser what? Weight. Maybe here it was reading 50 Newton. No, but here spring balance is to measure weight. When you put the body in water, you now see the spring balance will measure maybe 30 Newton. You now be wondering, where is the 20 Newton? Where does it go? It's not spiritual. It is because what? It's not something you go to church and give thanksgiving for, that the weight has been lost. This is just scientific. Because when the body is placed in water, it's very easy that the word, you know that there will be an helping hand, which is an upward force, and that upward force is what we call upthrust, and it acts in liquid. The body. So there is this one now, is not the real weight, it's called apparent weight of the body in water or in liquid. This is the real weight. Why the upthrust is now what? Apparent loss in what? In weight, which is calculated as what? 50 minus what? 30. And what this 30 recorded is the tension. This tension like this. The tension. So the tension now is what? Equal to MO G minus GL V not G. But what about if everything does not enter? The fraction that enter is what you are going to put here. You know, the fraction in water is the weight of what? Liquid displaced. Don't forget, please. Very, very important to know that. Very, very important to know that. If you don't know that, I don't think you can solve any problem. Now, I've answered that question, please. You can have it. Now, what is flotation now? Is flotation one time? Flotation. I want to go to this last part, but we don't have time again. Flotation will not take us too much time. Where I will explain it. Because this topic is very technical. That's why I'm taking my time. It's very easy and also very, if you understand it very well, you enjoy a lot of questions. I mean it. And this part I'm explaining, volume of liquid displaced. Most textbooks that will not tell you what it means. So when you now go to question, you'll be confused. We are giving two density of object, density of liquid. You now become, which one should I use? Many of us are solving these question on density by trial and error. You don't understand it. So take your time. Make sure you rewatch this video, and please subscribe to this channel if you are just watching for the first time, and share the link to others. Share the link to others, please. Flotation. Principle. It states that a body what floats, or a floating body displays what? Its own weight of the fluid in which it floats. It states that what? A floating body displays its what? Its own weight in which it what? It floats. So that means what? That when a body can only float in water because it displaces its own weight of the fluid in which it floats. What is that saying? That grammar is too much. What he's saying now is that, let me come back to your level so that you can understand. He's saying that when a body floats, the weight of that body displaced is equal to the upthrust. That is to say, for a flotation to occur, there must be equilibrium. For a flotation to occur, there must be what? Equilibrium. And somebody have said that. Yes, that statement is worldwide. Anybody that is listening, whether you are from Nigeria or from US or anything, you know what I'm saying. If you don't know it now. That a body will float only when the weight is equal to upthrust. So I can define what? A flotation, the principle of flotation says that the weight of the object is equal to the upthrust of the body experienced in water or in liquid. So the upthrust of the body experienced in liquid is equal to the weight of the object. It's correct like that. If you define what principle of flotation like that. The principle of flotation states that the upthrust of a body placed in liquid is, when immersed in a liquid, is equal to the weight of the body displaced. So that is just what, or weight of the liquid displaced. So that's how we say, now, what is weight? Weight is what? The mass of the object times gravity. What about the upthrust? Upthrust is equal to what? The density of the liquid, that the volume of liquid displaced times gravity. I think I've explained that one before. I don't need to explain too much about that. I've explained volume of liquid displaced. So that means in this case now, for a body to float, there must be some fraction outside and some fraction inside. In flotation, everything cannot just be what? In water. If everything is in water, that means that what? Volume of the object is equal to what? Volume of the liquid displaced. Don't forget, I beg. The volume of the object equal to volume of liquid displaced only when it's what? Totally in mass. So most at times, we don't have what? Volume of liquid displaced in question. What you are going to be given is mass of the object and density of the object. So you just find what? Mass divided by what? Density, you get volume of the object. You take it as that. But when it's partially in mass, the volume of the liquid displaced is what? Then let everything be total volume from here to here. The volume of the object is everything here, like this. Then volume above the water is what? V above. This one say, does it mean that upthrust slash divided by weight of the object completely what? Immersed when of the object when completely immersed in liquid is greater than weight in air? I don't understand that question. Now, whether you want weight in air is always greater than whether it's partially immersed or completely immersed. Let me just, in as much some part of it is in water, some part of it is in water, it will be what? Lesser than in weight. So let's move ahead because time is on our side. Now, if I want to calculate the fraction that is displaced in water, so fraction of liquid displaced in water, in liquids, or fraction of the what? Of body, sorry, displaced in liquid is equal to what? The liquid displaced divided by what? The total volume. Please take note of that. The fraction of the liquid displaced is equal to what? The volume of liquid displaced divided by the what? Total volume. What is total volume? The volume of liquid displaced divided by what? Volume of the object. That's what we mean by fraction of the body displaced in water. Now, sometimes they can give you the density of the body. We know that what? Weight of the what? Of the body, weight of what? Of the body is equal to what? Weight of what? Of the liquid displaced. Please take note of that. Weight of the body is what? This one. Weight of liquid displaced is upthrust. Don't forget, weight of liquid displaced is another name for upthrust. So that means they use one documentary like that. Here they what? A very big man jump inside the water and displace a sea. There was a documentary on social media that with a very big man, they show you how big that if that kind of man should jump on anybody. Let me not see what will happen. So then now say that man jump in a particular swimming pool, he now displace a river. They are trying to tell you what kind of displacement the weight will produce. So the weight of the body is equal to what? Weight of the liquid displaced. So that is to say that the weight of the body, which is Wmg, equal to what? That. Now let's go. Now, what are the conditions for density to flotation to occur? Number one, the density of the liquid must be higher than the density of the body that floats. The density of the body is less than the what? Than the density of liquid in which it floats. So that means that the density for a ship to float in water, it means that the ship must produce a density that is lesser than density of the water. When somebody died, when you cannot float in water, you know why? Because your density is higher than what density of water. But when somebody died in water, must have soak a lot of water. At the end of the day, it will not float. Why? Because at that point, it has what produce a density. That time, its eyes and everything will not be white. It has so all the blood in the body have turned to water. So that means that it has acquired a lesser density than density of the water, so it will not float in water. Such a person is a dead person. I pray that God will not allow us to explain such scenario in Jesus' name. We will only be explaining it, but nobody pray to experience it. Because science is good to explain, but the experience is better. Now let's go, because we have lost anywhere I stop. I think because of the technicality of the word of this, we are what? Number two, the density is inverse equal to what? To volume. So that means that the volume of the what? Of the body floating should be what? Is greater than what? The volume of the what? Of water in which it floats. That is to say that the higher the density, the what? The higher the flotation. The lesser the density, the lesser the flotation. That is to say, a body sink lower in a lower density, and what? Sink higher in a higher density. Let's talk a what? Let's say salt water and fresh water, for instance. If we take a salt water and fresh water, look at the board. A salt water is having a higher density than what? Than fresh water. Why? Because this one contains some impurity. So in that case, now, when you place a body, the same body, the body will have the same upthrust in the two body, because that is the same body. But we have a what? The sinking level is different. This one is what? Higher density. This is what? Lower density. So when you place the body here, what happens is that it will sink less. Look at it. Look at the fraction that is what? Inside the water. And look at the fraction that is above. But in this case, now, what do you notice? It will now sink what? More. The same level. But in this case now, there will not be more what? Body inside the water. So now, in this case now, what do you notice about it? The volume above has what? Been what? Decrease. Now, it was, let's say here, it probably is 10 centimeter cube above before, while it was 2 centimeter cube below. Everything 12 centimeter from 12 centimeter cube. But now, we now have 3 centimeter cube above and what? 9 centimeter cube below. See 12 centimeter. So that is to say, the upthrust in both of them will still be the same. Please take note of that too, because we are using the same body of maybe 10 kg, 10 kg. Why is the upthrust going to be the same? Because the two of them have the same weight. The weight of this body is the same weight of this body that will place in this place. So the weight of this one is 100 Newton. The weight of the body here is low and what does not sink more in what higher density. So a body what sink lower, that means go down lower in what liquid of lower density. Take note of that. And what sink higher, that means come up higher in a higher density. Sinking has to do with depth. So when we say sink lower, means that go down more in a lower density, and sink higher means that come up. It has to do with depth. I mean, sink higher means that it comes up higher in a higher density. Please take note of that principle. Very, very important. And the last one for the last condition is that, don't forget, under this condition, we can say the volume of the object placed in water displaced what? Higher volume than what? Greater than what? Higher volume than what? The volume of the what? Of the liquid itself. Meaning that the volume of why? Because the body have a lesser density but higher volume. That is, the body here, what density of the body is less. Then what is the volume of the body here? Will be higher. So that is it. Then the last one is weight must be equal to what? Upthrust. Weight must be equal to upthrust. Let's listen to some of the questions here. What if the two weight of the what? Of the two weight are unequal, but what? What if what? Two equal weights of unequal volume. Now listen. Since except we change the material, if the material here is the same, maybe here is steel, you have the same density. Except you want to produce your own by what? Standard, steel have a density. Iron have a density. Aluminium has a density. Type now and say what is density of aluminium? They will tell you. Steel have and what a density also. So you cannot, except you now indicate of different materials. You must indicate. So the one with higher what mass of different material, we related to density because we have to relate to with their density. Then if you have different density, then we will have what? The one with higher density we now will take the day. But in this case, we are talking about the same thing like upthrust. The same upthrust because they have the same material, the same mass. They will have the in as much they have equal weight. Please take note of that. Equal weight for your level. If they have equal weight, they will produce equal upthrust. But the one we sink more with what? We sink lower for lower density and we sink higher for higher density. Please take note of that. Very important. You know that. Now, there are three applications. Let me round it up here. Application of what? Of flotation, which I will explain in my video because time does not permit. I will explain it in normal playlist video. Application of what? Flotation, because time does not permit us. It is applied under what? Hydrometer. Application of flotation applies to hydrometer. What is an hydrometer? Hydrometer is a what? A long, narrow step. That is number one. The relative density is used to mark or calibrate the hydrometer. That is number two. Number three, it has a wider what? A wider bulb. Wider bulb. That means the bulb is wider. That means, look at the hydrometer here. This is how it is. This is hydrometer. Then there is what? Less short here. We call it less short. That less short will give it what? Ability to stand upright in what? In liquid. So that is what we call less short. Please take care of that. Now, these calibration are what? Representing what? Let's say 0.2, 0.4, 0.6, 0.8, 1.0 like that. So these are represent what? Let me not put 1.0. 1.0 is water. So let me what we compare them with water. So now they stand what? It's what is a bulb is what is loaded with what? In a way that will make the what the hydrometer stand erect. Hydrometer is used to measure density using what the principle of flotation. Please take note of that. And when they are measuring what this what do you call it density, the volume of water, we compare them with volume of water, the density of water. The volume of water will fill this place with what? With liquid, and fill it with water to do comparison. When you fill it with liquid, you have LW, area of water, water. Then if you fill it with liquid, the volume of liquid, not what? Length of what? Of liquid times area of liquid. Now the length is what? Talking about the sinking of the what? The length at which the amount of sinking is what we call length, or we call it height, as the case may be. The height at which the what hydrometer went in. Then the height when it went in what? Don't forget, area of liquid equal to what? Area of water, because we are using the same container. So the same container that is cemented. So the area that will occupy here is the same area that will be occupied by liquid and water. So that the two of them will cancel each other. Now you can now compare. Now the weight of what? Of liquid is equal to weight of water. Why? Because weight of water. Why? Because when you place hydrometer of the same, hydrometer has a mass. You understand? And because it has a mass, it has a weight. So the weight of the hydrometer in that liquid is the same weight in that water. So if I put hydrometer in kerosene and I put the same hydrometer in water, the weight of the what? Of the hydrometer in liquid is equal to the weight of the hydrometer in water. In that kerosene, just that in kerosene, it will sink more, while in water, it will sink higher. Why? Because water has a higher density than kerosene. So in that case, it will what? To measure the relative density. When you what? Also, hydrometer can be used to what? Measure relative density of what? Of liquid. You can convert relative density to water. So density of water times volume of water equal to density of liquid times volume of liquid. So in that case, now what do? We can now take this one here and take this one here. So now volume of water over volume of liquid equal to what? Density of liquid over density of water. Now what am I saying now is that this is weight of water, this is weight of liquid. Don't forget, weight is what? I'm supposed to put G here, but you know G will cancel out now. Weight is equal to mass times gravity. Mass is what? Density times volume. Then if you multiply it by G, you are going to have density times volume times gravity. So that is, if you this one cancel this one now, you are going to have this. So I want to remove this one here. I want to remove this one here. So what do? Or I want to remove this particular one here. I want to remove this volume of liquid here. What do? Divide both sides by volume of liquid times density of water. Volume of liquid times density of water. What you are going to have is this one. Please take note of that. Very important. Similarly, it can also be what? Height of water over height of liquid equal to density of what? Liquid over density of water. Please take note of this. Very important for hydrometer. It's talking about depth. So I saw in a textbook that a body denser than what? Than the liquid will float. If yes, a body that what? That is denser. Denser means higher density. We float. Let's see. We float what? Higher than the liquid we float. So I saw in a textbook that a body denser than the liquid will float. Denser than liquid will float. If the body is shaped to displace its own weight in which it floats. Now, look at the word. If the body is shaped to what? To displace its own weight. Whenever the weight is equal to upthrust, then the body will what? Will float. In as much this one occur. Then another thing again, if density is what, the body is denser than what? Than the liquid in which it floats. Look at it too. It can only be equal or what? Greater. If it's equal, probably it can float. If it's less, the body have to produce a lesser density than what the liquid in which it floats. it will float. But when it's what having a higher density and it floats, it's no longer called flotation. That is surface tension. Because surface tension now, if you put a needle in water, the needle will float. But the needle have a higher density than water. Yes, so it's no longer law of flotation any longer. Have you not seen a heavier body float in water? That is surface tension. Surface tension is different from what? From the flotation. A body can float but does not apply principle of flotation. Please take note of that. Very important. Now, when you get, I'm giving you an assignment to go and do for me. Go and explain balloon. The principle of balloon. Don't forget submarine. How it works. Submarine work with the principle of flotation. How? The ballast tank on both sides of the submarine. There's a ballast tank in what? The submarine. That ballast tank of that submarine can take in water. When it takes in water, it goes what? Inside the water. But when it what? It's compressed air of that particular ballast tank, it will now, there's a ballast tank, they will not displace the water. As the ballast tank compressed air, it will displace what? Water from the ballast tank, and the submarine rise up. Then they can attack their enemy. Then what? A boat and ship can float in water. Somebody has said, but the ship is made with, yes, but there is a hollow cavity in the water that is built with, that they use in what? Designing the what? The ship and the boat. And that hollow cavity is containing air, and air is denser than water. Don't forget. So therefore, that boat will float in water because of what? That air that is enclosing the what? The hollow cavity that is used to design the boat or the ship is what? Lesser than what? So, but something to float, please take note that. I don't know where you are reading, which textbook you are using. What I know worldwide is that not only Hydrometer's concept, you can go and read good textbook. Because the density of the body should be less than density of what? Of the what? Liquid in which it floats, or it should equal to it. Please take note of that. So go and explain balloon principles. I think I'm done. So I'm done with the topic. But the only thing that we cannot do this night because of time is what? They are already signaling me. My wife has signaled me. My manager have also signaled me, which is Engineer Samuel, and that we have to leave the studio now. Then please, I want you to do one thing for me. I beg you in the name of God, help us to share this video. If you know you want us, this will encourage us to do more. Help us to share for other people to see, because there are so many people that are having problem with this topic, that you can be a savior, you can be the Messiah to them by just simply what? Telling them about this channel and let them subscribe to the channel. Please, let them subscribe, let them know about this channel so that they can be blessed in their various cities, whether they are in Lagos, Port Harcourt, or Benin City, Delta State. They can always want. So please ensure you subscribe to this channel. God bless you. In case you have any question, quickly what? Yes? Okay, my textbook, you can just reach out to us. My textbook is 5,000 naira. You can just reach out to us. We can. I don't want to use this platform as advert, but just drop. I'm not doing any advert of anything here. Please just shut me up. This class is strictly for teaching. You understand now? It's not a class for selling anything. That's why we don't allow anybody to post any tutorial or post anything here. It's just for everybody to learn. We don't want to segregate that, okay, this person should learn, this one should not learn, or this one belongs to this one. It's a vision that I want to spread the knowledge across the nation. So please help us to share the word, information around across the nation, so that we can be encouraged to do more. It takes us a lot of money, a lot of time, and able to make this thing happen. But we can be encouraged to do more and do more as we they encourage us. Please, you can also type on the comment section how the class have helped you. We can always be corrected. Don't worry. We can always also listen to you to become better. Maybe our signal or anything is bad. Please comment, write that on the comment section. If you want us to teach a topic that is giving you problem, send it and write it at the comment section. I don't think we separate a particular topic for this class. It's the topic that people have chosen is what we put on the board. So you have my number 08133355411 to send the topic you desire. And when we see the number of people that send the topic to us with this what we are going to do. So that we are done with this topic. Please, I will do the calculation on the playlist because I don't want to come back to for part 3 again to do question. Then if you have any questions, please send it to me. I will reply you on this one. Then we'll do the playlist. We'll do a video and send it to our playlist where you can see calculations on upthrust and density. Every type of question they can ask, we are going to solve it there. So thank you very much. God bless you. I wish you success and God will give you more understanding than what you have learned this night. Thank you very much for being with us and also joining us at this hour. Thank you. God bless you.